Yes, we get started. Business development here today. So, this one quick announcement. We get a BLA. Just mentioning that again. If you haven't signed up, please go to our website and sign up. We already have quality and speakers. It's going to be a great idea. Finalizing the talks by June 15th, will be announcing the list of talks out. Please go to the setup. It's going to be a good failure. This conference call is there.
Okay, thanks a lot. Are you streaming over here?
Yeah, what's the recording?
Are you recording that? Do you see me or just this one?
I see you too.
Okay. Hi, everybody. Sounds okay in the back? My voice good. Hey, sorry we're getting late. We took a nice tour of the campus and crashed somebody else's meetup. There were a lot of 12-year-old kids in there who had absolutely zero interest in data lakes. But we found the right place. Sorry we're getting late start. My name is Cappiello. I lead product management at Paxata. My colleague is Chris Fowler, manager of sales in West Coast for us. A little bit of anticipation just to gauge things. We're at datascience.com. How many of you would identify as a data scientist? A couple? Yeah, a couple, three. How many of you are in an organization that has a data lake currently? A couple? Okay, we got everybody? Okay. How about enterprise data warehouse? Okay, more hands on data warehouse and data lake. Okay, good. So I'm going to give a little talk today about how we can really take advantage of a couple trends in the enterprise analytics space. And the term data lake and getting value out of it sometimes is kind of the buzzword of this talk. We do run into customers that we work with, clients that have data lakes that exist, but they're still scratching their heads about how do we actually get value out of it. And I think we have some beliefs at Paxata about some ways to do that, and I'm going to tell you about them today. So so in our view, the key to value is really answering this question. This is what we're after. Is how do we get business people to change raw data into useful information? Right? There's some key terms in this question. Number one is business people, right? That we believe at Paxata to really unlock value out of data assets. We've got to emerge beyond the small group of people that have the ability to know how to do it and really get out to the larger groups of people that can really take advantage of the data assets. That means business people. Of course, today we're swimming in data. We've got lots of raw data from different sources, from more sources than we've ever had before. But for those business people, there's still a barrier between that raw data and information they can actually take action on. Because action is where the value. So this is the question: is how do we get business people to transform raw data into useful information? So I've drawn this distinction, but what do I really mean? So most organizations today have tons of raw data from the various systems listed here, right? The CRM systems, whether it's from financial systems, maybe it's third parties, like Dun & Bradstreet, maybe it's new streaming sources, log files, IoT data, social media. There's all different sources of data. And data warehousing was supposed to solve this problem, right? We're supposed to have a distinction between operational systems and curated data in a data warehouse, but it seems like our appetite for new sources of data is never ending. That's always going to be true. So there's always going to be raw data in the world. But again, in order to have insight, be able to take action, we need to transform it into something that has the 4 C's that are listed here, right? Data needs to be complete. It needs to be a comprehensive picture of data. It needs to be clean, meaning a lot of data, a lot of raw data may have may be hand coded. It may not conform to a set of standardized rules. It's got to be clean before we can really take action on it. It needs to be contextual, right? It needs to be relevant to the usage at hand, to the usage of a business user. And finally, it needs to be consumable. It needs to be ready to eat, and that could be for a business user. It could be for another system, right? It's got to be ready in the format for use by the system or person needs to use. That's really the difference between raw data and information. And that's the transformation that we need to make now. As I mentioned, this problem is not new, right? We've been swimming in data for a long time, right? Maybe the sources have changed over the years. Maybe machine-generated data is more prevalent today than it was 10 years ago. But the general problem of turning raw data into actionable information is not really new. And there has been a canonical architecture for doing this in the past, which really consists of this triumvirate of a data integration tool, an ETL tool that transforms data, puts it into a curated location like an enterprise data warehouse, and then you put business intelligence tools for business users on top of that. Those are the three pieces of the puzzle, the three layers of the cake that can turn, in some cases, some data, raw data, into useful information. However, we've stretched this canonical architecture, and we've realized the limitations of this stuff here. In today's world, this traditional architecture falls short. Number one, because the tools involved are for IT professionals mostly, especially in that data integration layer. ETL tools have programming languages, and they have certified specialists that know how to use the ETL tools that are listed here. Right? So they're really geared towards more of a developer mindset than the business people that we're trying to help unlock data and information. They're also optimized for what I would call batch workloads, right? There's the canonical example is the retail point of sale data on a periodic basis, where that period could be getting shorter, but it's still from weeks down to days, maybe get down to hours. But they're optimized for batch workloads, where you can think of it as you have to have an abstract thinking ability. Think of it as a process that you're going to run and get your answer at some later point in time. And that mode of operation doesn't really work for the non-IT professional, right? The non-IT professional is used to instant gratification from our experiences with information in the consumer world. But even in the business world, a business user is used to being able to interact with data set in Excel. It's a very different experience than thinking through workflows. So the existing world is optimized for batch workflows. Generally, they consist of fragmented solutions. Again, this architecture is built up over a period of 15 or 20 years. The tooling that's out there has been accumulated by acquisition over time. So there's multiple solutions that have not necessarily organically grown together in this course. It's also been focused on primarily relational data. It's the relational database is a good Swiss Army knife. There's a lot of things. It's pretty versatile. But again, the new and emerging sets of data are much broader than what relational data is. Right? We've got semi-structured data sets, either JSON or XML format. We've got free text, unstructured data, social media. So there's a much wider variety of data available. And then also on the technical side, the architecture was built for really a scale-up architecture, use bigger machines if you want to work with more data. The modern data architecture has really turned that into a scale-out preference. In order to get the big data volumes, you need to have a scale-out architecture. Also, they're more primarily focused on premises, and of course now in the age of the cloud, so there's some other deployment differences between what's been going on in tradition. Make sense so far? Does this resonate with those of you who said you have an enterprise data warehouse? Sound familiar? Okay. So when you summarize this problem, what we wind up with is two different pools of people, right? Trying to turn raw data into information. On the one hand, we have developers, specialists, IT generally, that don't understand the data all the time as well as business users who really understand the business value of data. However, they don't understand the tools or have the skills of the tools in order to make that transition. So we have this breakdown. And we all recognize that 80% of effort in any analytic initiative is really spent on that data preparation. The problem with having these two groups of people is that we end up with a business user community creating a requirements document, sending it over the fence to an ETL team who either doesn't have time to get to it or sits in their backlog. When they do get to it, they implement something that wasn't quite what the user asked for, or the user asked for not quite the right way, so we can go back and forth. And that's what makes this process broken, by having these two. So the observation I'll make is that there are two trends in the enterprise analytics world today that are pulling that old world work apart. Number one is a movement from more centralized and controlled transformation of data insight to more of a self-service approach. So one is the move to self-service, and then the second one is more of the modern data architecture moving away from curated data warehouses into more raw data lakes. So let me talk about the first one. What this slide is showing is that we've seen in various layers of the stack how technologies have moved from centralized, managed, and curated delivery of data to more of a self-service model. So we've seen it in analytic applications, from really complex systems like the traditional ERP systems to the cloud-based software as a service models for delivering applications. We've seen this in the BI world, from heavily modeled tools that build a semantic layer, and then you can do your reporting on top of that layer, to more self-service tools where business users, business analysts can go directly at data and answer questions for themselves. We've also seen advanced analytics, and to some degree we've seen changes even in the data management. What we recognized at Paxata was this transition hasn't completely happened for the enterprise information management space, for anything that's data integration, or data quality, or data profiling. We still have a traditional heritage of really central tools used by experts. So that layer of the pie, or that layer of the cake, hasn't completely moved to self-service yet. And then the other trend I'll mention is the characteristics of the data store that we're accessing have changed, right? Again, the data warehouse was supposed to be this place where we collect multiple sources of data, put it into a format that facilitates analysis as opposed to operational updating. But there's limitations to that model that the modern enterprise is now addressing. A big one is the ability to deal with change, right? That if you want to have a curated model, there's still a place for that, but it takes time to go through that curation process. And there's been a recognized need to be able to optimize more for speed. That if there is a data feed that's available, can we bring it into an architecture that makes that available for analysis much quicker? Also, the modern enterprise needs to allow the flexibility to not have to do modeling up front. Right? There still may be a model, but this is the schema on read dynamic of data lakes. There is a schema, we just don't necessarily know it at the time we put data in. Right? So we can land data first and then apply a schema at the time that we're ready to read it. And it could be a different schema from one usage to another. As I mentioned, we're not limiting the format or structure of data. We want to open this up to sources of data that are not just structured tables and columns, but also more unstructured data or things in between, JSON files, log files that machines are spitting out. So there's been a shift in the way the data is stored in the organization. I want to draw one more distinction around the self-service mode of operation. And what this slide is showing, this is actually some research that was put together by Gartner. And it shows their view of BI architectures back in 2012 versus more recently in 2016. And you can see how their thinking has shifted. And I think it's reflective of what the industry is understanding too, right? In 2012, the idea of self-service BI was strictly this, the single dimension of how much is it centralized and controlled on the left, represented by traditional BI tools like MicroStrategy business objects, versus totally decentralized and a little bit of the Wild West, where it's called here the dark side, that's completely decentralized. Let people add the data with Excel. They bring it into local extracts. You have no idea what the users are doing. There's no single version of the truth across the enterprise. And then self-service BI was supposed to kind of bridge that gap somewhere in between. 4 years later, it's a much more layered and nuanced approach, right? It's not just a single dimension. It's more of a recognition that there's multiple layers, even in the analytics stack, right? That there's different user communities, for instance. You know, the profile of the user who uses an information portal is different from the business analyst who's using analytics workbench. It's different from a data scientist who's doing more experimentation. But there's an interplay between each of these user communities, and we need a data architecture that will support that interplay. So it's a much more layered approach than what we've seen before. Okay, so those are the two dynamics that are happening in the enterprise analytics space today, right? At the data level of more flexible and layered data lake, as well as a more flexible and layered self-service approach to doing analytics. But there's still this problem still persists, and this is where Paxata was really envisioned being able to help the industry with this transition. Is that for a variety of user profiles, we still need to be able to bridge this gap between data becoming available but more raw, but more people being able to access it with self-service tools. So data is more raw, but more people with less skills have access to it. I mean, there's a bigger chasm to cross in going from that raw data to useful information. And we're serving that chasm with a variety of communities, right? There's a data science community of specialists with deep technical skills. As we come a little further down the technical spectrum of data developers or data engineers that understand data well enough to process it and curate for someone else. But where Paxata really wants to focus is starting in on that business analyst, the larger group of people. We think that if we can put the tool and ability in the hands of a larger group of people, we'll be able to unlock more of that data and information transition much more quickly. And eventually, our vision is to break out the even larger, less technical information workers over time, but we're really focused on that business analyst right now. So this is the essence of the challenge and what Paxata has set out to create. Is we imagine a platform that allows you to go from raw data, again, more raw than it's been in the past, on the one hand, and make it available for a variety of analytic, self-service analytic tools on the left-hand side. Again, not that it's strictly for self-service tools, but we still can use our platform with some of the traditional tools like MicroStrategy or business objects. We can still use the tool with existing data assets that are in data warehouses or other legacy systems. But we want to fill this gap with data that's more raw, so users should have more self-service access to. And the essence of this platform is to be able to do an iterative process that is depicted in the circle here. Number one, you want to be able to gather the data that's out there in the various sources that you may have access to. You want to be able to explore it, just see what's out there and available. You may want to clean it. You may want to combine it. You may want to enrich it with other sources. You may want to reshape it in order to make it available for analysis. And this process is iterative, right? You can shape it a little bit, come back and gather a little more data, combine that with another source, reclassify it or re-clean it, go through this circle in an iterative manner. And then when you're ready, you can publish that out in what we call an answer set, which really represents the clean, consumable, contextual, and complete information that you can then make available for downstream. Make sense so far, President? And one more slide just to reiterate the point that, if we can contrast this with the traditional model versus what we think needs to exist today, again, we've got a data lake that is more raw, more layered, more flexible. We believe you need a platform to be able to do that transition from this raw data to more of the self-service tools that use it. But these other areas are important too, to recognize that the platform is not exclusive to a data lake. We can still use existing data assets like an enterprise data warehouse or even legacy systems that feed those sources. But the point is that there's not, and you're not required to pre-model data in order to be able to convert it into useful information. Yeah, question.
For someone doing the final analysis, and for example, I'm probably going ahead and I do have more data. But as you said, that I move the data, I convert the data into the form that I want to. So some people, for example, you have to actually do something.
Sure.
So when you say that knowledge is
Sure. Sure. So again, we're targeting a business analyst audience, and that's really where code free is necessary. It's not to say that you can pass it on to a coding environment where you can use code to work with it. The other thing to say is that even people who have the skills and ability to write code may prefer the productivity gain, not having to. Right? I'm going to spend a lot of my time in a traditional BI world. I'm very handy with SQL. I'm happy to use a tool with a point-click interface. I can be more productive in doing that. I could write the SQL myself, but I don't have to. I'm happy to use a clicks approach instead of writing it myself. So I think there is benefit for both, being code free, both for a business analyst who may not have the skills at all, or for someone who does have the skills, just getting productivity gain. I'm happy to, right? And saving their skills for maybe more of the downstream process where there's not opportunities, say, building custom predictive models, there may not be as much room for off-the-shelf modeling tools that you've got to get in there and have flexibility by training. Okay, so as we set out to build this platform, there were really 4 pillars that we felt were really essential to the product. Number one, I think I've hammered this a lot, is that it needs to be built for analysts. That's the focus user to get out to the broadest number of people that can actually do this transformation of data and insights. It's got to be focused on that analyst. At the same time, it's got to be enabled and improved by IT. Right? We've learned some lessons from the transition that the BI tools went through, and maybe going too far on the self-service side, where there was a loss of single version of the truth, or a loss of traceability. So we need to make sure the platform, even though it focuses on end user flexibility, provides that flexibility for end users, it's got to be done in a way that we can still ensure data governance, we can still apply security, we still have traceability and auditability. It's got to be enabled and endorsed by IT, even though it's really built for analysts. Number 2, as a means to the end of being built for analysts, we want to take advantage of algorithmic techniques that make that analyst's job easier. If we can inject intelligence on behalf of an analyst, we'll do a much better job of really achieving that goal of giving a tool that a business user can use. Related to that is just the ability to work in a schema optional world that is the new reality of the modern data architecture. We're not going to necessarily guarantee models known up front. We've got to be able to work with semi-structured and unstructured forms of data. The third pillar on the bottom left is we really recognize that we need to have a unified platform, right? A single platform that can handle the wide variety of data and information activity. So it has to include profiling, it has to include data quality cleansing, it has to include data integration, it's got to include the ability to collaborate, it's got to include the ability to have all those processes go. All those within a single umbrella. Again, as opposed to the prior state of the art, where each of these capabilities may have grown up in different tools. And finally, we recognize that we have to provide deployment flexibility for the reality that is the current IT landscape today. There's organizations that prefer to deploy on premises. There's those that prefer to deploy in the cloud. There's those that prefer to use a SaaS offering where there's nothing for them to manage at all. So we need to have a platform that supports all those different. Okay, so let me go into a little bit of detail on each of these, and then I will show a very brief demo on give you a better idea of what these are. So, I mentioned being built for analysts, but enabled for IT. And this is a good visual of what this means for both these audiences. So for the analyst, you know, an analyst working with data is used to tools like Excel, right? It's a spreadsheet-like interface where you can actually see the data. You know, we need to have fundamentally a paradigm that's focused on being able to see data in Excel. Use visualization techniques to allow you to do profiling. And so we've got these filter histograms across the top. So we need to play into the paradigms that a business analyst will be familiar with and will be comfortable with. So play the tools that they know in Excel and with visual paradigms, and we'll be able to work with clicks, not code, another catchphrase from Paxata, that anything that you want to do to manipulate this data, you can do via clicks without having to go down to writing code if you want to. At the same time, providing that flexibility, we need behind the scenes to be able to track what people are doing with it. So unlike Excel, where you can manipulate data, do whatever you want with it, there's no record of what happened to it. You know, our idea is to make sure that no matter what the analyst does in this visual interactive interface, we're actually reporting everything that happens along the way. So we've got an auditable, repeatable, traceable record of what's happening. In addition to that, in addition to capturing the individual steps, we also want to capture the versions of it. So if you need to go back and understand, and looking at this reported data, what actually happened to this particular version, we want to be able to trace those versions for you automatically. And if you need to revert to it, you have that ability to go back. So we've got full repeatability, traceability, that will make makes IT happen. Again, look at these two pictures. I mentioned we want to make sure that we have a unified platform that provides all 5 of these styles of activities. So I mentioned data integration, being able to join in data from other sources, being able to shape the data in a way that it can be integrated with other sources. A great example is if you ever get an Excel spreadsheet that has, it's a monthly report, it's got months across the top in columns, and then you go into your relational database where we all know that time should be normalized into a separate column of itself. How can I bring those two things together? So you got to be able to, what we call depivot the data so that you can integrate it together. We want to build quality into the same platform, so the ability to quickly profile data and then standardize it, so we can remove similar value or standardize similar values, make them all the same value. That's all going to be baked into the same platform quality. Also, the ability to do enrichment, so being able to attach data from other sources, and you can suggest or recommend to the user what additional data might be available of interest to them. And as I mentioned, for the enabled by IT, we make sure we have the ability to govern conversions and the ability to collaborate, the ability to share a single data preparation with multiple users that we work on the system. Here's one example of in the pillar of using algorithmic intelligence. One of the technologies that Paxata has developed is what we call intelligent joint detection. So when you integrate data together, especially with raw data, there's not necessarily a good key to line up data from 2 different data sets. So we've developed some algorithms that will actually look at the individual data values, profile the values of data in every column within those data sets, and based on that fingerprint of data, recommend to the user what are the right columns to join. So not necessarily based on just the names of the columns, but actually on the values and even on the meaning of the data. So it's just an example of how we use algorithmic techniques to facilitate the data prep process. Okay, this one's a busy slide. I won't probably spend an hour on this one alone, but I just wanted to, this is really to represent the deployment pillar, that we have flexible deployments. We offer a SaaS product, an on-prem product. It's actually the same software, just deployed in a couple different ways. I do want to highlight a couple different pieces of this architecture. Our product consists of a couple different ways of accessing the system from a user experience, whether it's through a UI or a RESTful API, through the programmatic interface to it as well. I mentioned the different services that we make available in these 5 different styles of data prep. that are all packaged as web services available to these interfaces. I'm going to skip down to the stack that we're built on. I mentioned that the new data architecture is a scale-out architecture. So one of some of the key technologies we depend on includes Spark. We leverage Spark for its scale-out capabilities. We are a Spark application. So when we bring data into Paxata, we are loading that data into Spark, although in a very clever way that I'll mention in a bit. And then we can scale out based on the loading of Spark. So and we get this for free for using Spark. If you need to scale to larger data sets, you can scale out your Spark cluster and meet those things. Okay, so while we're based on Spark, what we've really built is this layer in between kind of the banana show over here, which is a very long caption of an elastic parallel pipeline data prep engine. So we built a data prep engine on top of Spark. So although we use Spark, when you load data into Paxata, we have the ability to load much larger data sets than what you can store in memory on your Spark cluster. We effectively bring data in, chop it up into small pieces, both by column and row, and cache those in our data prep engine. And the reason we do that is to provide an interactive response time for that business user. So this is really the magic of Paxata. This data prep engine is optimized for data prep. Right? It's a different kind of activity from BI tools or analytics that you do. It's optimized for doing data prep operations. And it enables a greater scale than what you're able to do with this plain vanilla Spark. And it's optimized for being interactive. The whole point of this, again, is getting back to that business user for interactive response. I won't quiz you on the rest of our very busy architecture. Okay, any questions here before I show you? I do want to talk about, this is kind of the theory so far, and I want to talk to you about getting value in your data lake, so I want to talk about some customer examples that we have that are actually doing that. And just to tee up some of those customer examples, I do want to show you just a couple of things in the product itself. I'll pause here in case there's any questions about what I talked about so far. Let's get through. Okay, so let me give you a brief demo of capabilities in Paxata. So again, Paxata has built an engine for interactive data prep at scale. So we're going to look at, in this case, I've got a simple data set that's not shown on the screen. Okay, so let me show you what this process of changing data into information looks like. What we're looking at right now is a list of projects. I'm going to give you one data preparation exercise, what we call a project in Paxata. I'm going to start with, I'm going to pick out a data set that's actually got a record of some drug therapies provided to cancer patients. So I've opened up a new project and pick out a data set. And what we've got in this data set, again, is really a row for every treatment that's been applied to a cancer patient. So you think of a drug cocktail given to part of maybe therapy. If you take a look at different columns that are available in this data set. So you can see we've got, a unique identifier for the patient. We've got scan code of when the patient comes in for their treatment, the drug that was used, right at outcomes from actually doing that therapy. You get a feel for the kind of data that's in this data set. Sorry, I got the demo enough. Okay, well, let's take a look in a little more detail at, I've got this column called drug name that I'm going to call your attention to. I also want to use a little bit of quick intelligence, again, for business users to be able to quickly identify some patterns in the data. We're using color coding to group together like values. So you can see that this is actually the same column, this first column, the same patient getting multiple drugs and multiple treatments. So let's take a little more detail of what some of these drugs are. So again, we're using our spreadsheet-like interface to view the data. So I can also bring up a filtergram to let me visually explore the data that's available. This shows me the unique values that are available in my data set. And as I kind of scan through, I get a sense of what some of them are, although you'll notice that some of these are written in all caps. And in fact, there might be some duplicate names. If I want to do a little filtering on those, so you can see, the same, in effect, it looks like the same drug is actually coded in multiple ways, right? This is real typical of raw data where there's typos in the data, entered incorrectly. Even worse, we've got some rows here where you can see there's multiple drugs that are put together in the same row, right? Like it's a cocktail that's all given at the same time. But those have been coded in a really incorrect way. I'd really like to get to is a single row for every drug that's ever given. So we already can tell that there's some cleanup that needs to happen with this data set. So let me start to do that. And again, by using clicks.code, I want to do I effectively want to split those this drug field on that plus field, on the plus column. We get to okay. The 12-year-olds are going to meet up for the night. All right, so let's do, we put, the idea of doing clicks.code is that you can put right on the context menu, the most common actions that somebody might do with the data set. So I want to take this drug name and I want to manipulate it. If you look at several of the manipulations we've got available, but the one I want to do in this case is what I call split, which I'm going to take that character where did I have the whole thing? And I want to split it on the plus. It tells me that there's some rows that have just that have one drug in them, and some that have four. So we need to make sure I catch all four of those. So it's actually creating in the blue. You can see a little preview of the data that we're working with. So you can see it's going to split out for me this original column into 4 new columns. Again, if you're a Python person, this is an easy split to do. In Python, with this clicks.code way of breaking out that data. And then as I scroll through the data set, I can scroll down. And by the way, this is showing windows of data. Again, as we load this data up in Spark, what you're looking at is just a little piece of that data that we need to show on the screen. So it's a little trick that we do to give the appearance to the user that they're really scrolling through a massive data set. They are, but we're only displaying just a little chunk of the data at one point in time. So that's one of the clever things we've done to get an interactive response for the user. So here you can see an example of broken out a combined drug into multiple columns. This is good, but it still doesn't quite give me one row for every drug that I need. I need to manipulate this data a little bit more. So I'm going to use a tool that we call shaping. And I'll actually change the shape of the data as well, not just the values, but actually the shape of the data. And there's a particular tool we call a dpivot. And this is the Excel example I mentioned before, where you get different columns across the top, and we're going to swoop those down into rows. That's what we're going to do. I can keep my eyes on the screen. So I'm going to take those 4 new columns I generated and ask the system to bring those down to the rows. And we're going to call this new column drug name. And I want to, so you can already see what it's doing. For every original row, now we're repeating, we're bringing those 4 drug names down the rows. This is the idea of shaping data so that it's ready for downstream analysis. I'm going to give you an example of shaping. I'm going to keep the rest of my columns. So with one click, I say get the rest of those columns for me. Again, it gives me a quick preview of what's going to happen when I actually hit save and okay this down. So what have we done so far? We've actually manipulated the data by doing a split. We've reshaped the data. Let's take a look now at if we filter back on this data and go back into profiling. We move back and forth between doing profiling, doing data quality, doing reshaping. We can see that for a lot of these drugs, they weren't entered correctly, so I have a set of blank rows. I'm going to try to click on them. Select the blank rows. And so this will select out the blanks, and let's just get rid of these and remove them. So now I should get a nice data set where there's 1 row for every drug name. So over here now I've got 1 drug name all the way all the way down. So let's check one last thing. Again, I mentioned algorithmic intelligence. How can we use? I want to give you another example of using algorithmic intelligence to make the business user experience a little better. So we've cleaned these up. We've got a good set of drug names, but we still have, again, some of these repeating values or slightly different encoded values. So we have another capability that we call cluster heading. Again, with a quick context menu, I can jump down and say, for this column, let me cluster all the different values that are in it. So it goes through my column of data, and it automatically detects values that are similar but not quite the same. And it shows me what those clusters are. It says, for instance, I've got a cluster here with 5 different representations that to me, that to the system look similar. They cover 257 different rows, and here's the 5 different ones we recognized, and how many of each of those. So 222 of this top one, and slightly fewer of the different variations. And here's the one I'm going to replace it with. So it's a way to standardize, identify these clusters, and then standardize them all with some quick mouse clicks. We have a couple different ways that we do this, a couple different algorithms we use. This one is using a phonetic algorithm that looks at values that, if pronounced out loud, would sound the same. We have some other ones that look at more at the way data looks, or at bigrams and trigrams of string values. But this one seems to work pretty well. So I'll do a quick scan of the different clusters that it's found. I can make any changes if I see something amiss as I go through. So for instance, maybe here I want number 5 to show, so I'll choose this value as the one to replace the values with. Maybe recognize that even though this looks similar, it actually is a completely different drug. So let's remove that from the cluster. Maybe same thing for this one. And maybe the rest of these I think look pretty good. So I'll scroll down to the bottom, look at the rest of my cluster. So it looks like we're cleaning up some data. Again, maybe this one I don't like the option out to use. I use this one instead. So I select all the clusters I'd like to use, and you can see in the preview how we're transforming some of these values. So you can see here we've corrected the value with the right peak selected. We've eliminated the all uppercase and picked the standardized value. So to save this away, now we've got a clean version of that column that used to be compressed into a single column with plus signs. We split it out and decoded it down. We've cleaned up the values. I should say, as we were collecting all this, I mentioned the steps. So we can go back and see all all the actions that I took, we can actually go back and see the full record of steps that we've taken in the process, right? So here's a nice summary of my demo, right? We did a split, we did a shape by depivoting it, we moved some rows, and we did a cluster.
Question, Mark?
Yeah, question.
The question steps on people is a pipeline. So is the pipeline explicit? Is it code, or is it just simply sort of that GUI interface that you see here? Sort of.
Yeah, so what we call the pipeline is actually what's working behind the scenes, right? So this is the user experience, right? I wanted just to highlight, because I'm going to go through some customer examples. I just want to show you some of these operations, like the splitting and the depivoting and the clustering. I want to give you examples of what a business user can do. The pipeline is what's happening behind the scenes. It is really that data prep engine that is performing all those manipulations. So when I do a split, the user interface is telling the system, I need you to do a split. We have code that actually pushes that into Spark and actually executes that on the data that we're storing in Spark.
Is the code made explicit, or is it just only viewable the actual code?
Yeah, we do make our, we have a script, it's effectively it's our domain-specific language for performing these operations that we call scripts. That is, it is available. We target the UI as the main entry point for creating that script, but there is an underlying language for specifying those steps. Yeah. Makes sense?
And so this is the specific language that you guys created.
It's essentially our scripting language. So it includes things like we want to do a cluster and edit, and here's the options we want you to do. We want you to do a depivot, here's the columns to put on the rows, and here's the rows to put on the columns, right? So it's those kind of parameters you send, and it's a description of every step. Yeah, question.
When you were doing all those steps, manipulating, shaping, splitting,
yeah.
I know I understand the data is looking Spark and memory.
Yeah.
Is it also embedded back to the original? So are you actually just creating a model essentially?
Yeah. Yeah, so a couple of things to clarify. We were using Spark. The full data set at any one point in time is not necessarily memory. Okay, right? So remember, as we scroll down, we saw little bits and pieces. So that's just a little piece that we bring up into Spark.
Sampling?
We're not. No, it's essentially a caching mechanism that we built on top of Spark. And we say, look, this is a big data set. I want you to chop it up into smaller pieces. As I manipulate one column, I don't need all the rest of the columns, right? I only need one column. So the first part is that we're using Spark to work with just the data that you need to see. And that's really important because that's what gives us that interactive response.
If you profile data, you just do a scan?
Yes, so certain operations will do full scans. However, it's a scan of a single column. Right, so again, you have 1,000 columns, you profile that one column, we're only loading the data in that one column. We don't need to load the full data set. And that's the difference from loading a data frame or data set in Spark by itself. Spark will use some of its own smarts to operate on the data that it needs. But we've actually built, our engine is built on top of that. Again, with all this in mind, of how can we optimize so we only show you, only operate on the data.
You're actually doing the transaction, is it affecting the actual source of data?
It's not. No, it's not. You can cache a copy of the data, and then we're creating additional new caches. But again, only on the data that you need to see, right? So even though I've done a cluster edit, would do a full, but even if I've done a split, I'm not actually going to perform that on the full data set until you go to look at that column. At that point, then I'll go ahead and do the split. So that's what gives us the fast response time. Because we're calculating that for the preview. Right? We show you have 400 rows, and it comes back really fast, right? You can have 10 million in that column, and we're not going to actually perform that until we need to. What you can also do, and I just didn't show it in the demo, you can also, once I've created this answer set, I can then publish it out, so I can save it back to HDFS. At that point, you may need to go back and execute a lot of functionality that you just never do. You actually have to touch the rows because you want to dump it out. So it's similar to the sparse concept of just lazy evaluation, right? That we're only going to apply the steps that are needed when you need them, right? We're not going to do it then. Okay, let me stay on track here and talk a little bit about some customer use cases, but hopefully you saw a little example of each of these about exploring data, filter grading, shaping the data with pivoting, combining the combining data and then splitting data out. But again, it's an iterative process that we go through. Okay, but what are real people doing with the product? So here's the first use case, which is it says anti-money laundering here, but there's a challenge in financial services institutions around compliance with any process where authorities think that banks should be doing a better job of checking on who's doing what in their bank. Right? It includes, are banks doing enough to monitor for money laundering? Are banks doing enough for politically exposed persons? Right? There's anybody who's like an elected official or is on a bad guy list. Are you as a bank doing enough to watch the accounts and the transactions that come through your system to see if any fishy activities around people who should be who should have a higher propensity or higher likelihood or chance of being involved with fraud and bribery. So this is a real problem for the banks because it's regulation for them. And if they don't comply with regulations, they get fined. And that's a big cost. And the customer we're working with here, over a 10-year period, actually fined $1 billion. And there are two examples down here. We got fined $300 million by the U.S. alone because their anti-money laundering systems were not up to snuff. They weren't doing enough in the eyes of the regulators to monitor money laundering. The way the process works, they have a group called Financial Crimes and Compliance. There's 3 different teams, got 3 different things they look for: money laundering, transactions with politically exposed persons, and then also just travel and expenses that they monitor. There's an IT-ish group that supports the data behind this, but there's a group of more business analysts who are actually doing the analysis, actually doing the investigation. So there's a line of business that really supports it. There's multiple business teams that are looking at reports for any suspicious activity that are subject matter experts, right? They're not necessarily data and tool experts, but they have a ton, 1,700 Excel users who know how to write some queries, but they're basically Excel users that are trying to keep up with these regulations, trying to keep themselves out of being fined, and they're throwing bodies at it, right? They're saying, look, if you know how to Excel, just take data extracts, spend 15 minutes looking at how to, and whether there's any phishing. Over 1,700 people, that's a really expensive cost. And the process looks something like this, right? For every one of these, flagged situations, businesses have to file a ticket request, an IT person has to go extract the data from them, they send it back, they look at it for 15 minutes, if there's anything wrong with that extract, they have to go back and get it again. So a very complicated process before they can say, yes, here's a report of suspicious activity that we need to look in. So the data they look at is pretty voluminous, right? It's more data that actually will fit an Excel spreadsheet oftentimes. So it could be up to 25 million records that they're looking at in one of these investigations. It's heavily dependent on Excel and a very manual process. A lot of reliance that these Excel users have on IT to provide data extracts to them. And the whole thing had to take into 21 days for an average investigation. A little more on the data architecture. Again, so this is all about things like data lakes. They do have data lakes, right? They have, again, it's a layered data lakes. They have one tier of data that they allow their analysts to work with. This green box is called FCC Transformer. That's essentially Paxata, that we were the transformer, that allows their business analysts to grab data, to do the projects just like I did, and then for the transactions or sets of transactions that are fishy, export those back out and create reports on top of those. They use a different tier of their data lake to do that. And then some of them, they may, bring in additional data. They may send it out to reporting tools like MicroStrategy and Tableau. So the process at Paxata was to start. This is specifically for politically exposed persons, right? These are elected officials or lists of people that need to be watched. They would start with a watch list that, by the way, they get from a third party. So they have to clean up the names because they don't control this list. They get it from regulators. It could be multiple countries, right? Different countries have different sets of people who are suspicious. So you clean up those names and you compare that to their own account list, Everybody's got an account at a bank. Once they line those up, now we can go and look at the transactions to see the suspicious activity, and then publish out interventions. So these are the kinds of things they did in their data preparation. And there's some of the things I showed in the demo, right? They did a split, right? They did a split on a comma because they had a single column that had a full name. They wanted to split on last name. They did cluster netted, right, to find potential duplicates, just like we did a cluster netted on the drug data set. They did it on top of names. They did some parsing out of the names, but ultimately they boiled down to a clean account list. They combined that with their known account list. They did a deep pivot, just like we did a deep pivot, to create a separate line for every person that they can then compare against their transaction. So the net of being able to do this process was that they were able to reduce their cycle time down to 1 day. So from 21 days down to 1 day. So huge cost savings. Not only was it faster to respond, but it saves them a ton in terms of the labor cost of having 1,700 analysts doing 21 days on 1 day, saving factor 21. So they save money in the headcount, but they also save money from being able to avoid more of the fines that we're getting from regulation. So with 4 minutes left, let me give you one other flavor of another customer who got value out of their data lake. This is a healthcare example, and this company is in the business of essentially payment reconciliation. So in healthcare, there's a lot of people who can potentially pay for a procedure. It could be government, so every state in the U.S. has a Medicaid agency. Sometimes they're responsible for payments. Sometimes it could be a third-party provider, like an insurance company. So they have 2 lines of business. One is called coordination benefits. That's where they really work for the state Medicaid agencies to describe who should be paying ahead of time, who should be paying for this procedure. Payment integrity is sort of after the fact, where they try to sign up health plans like big insurance companies to say, even though you pay this much in insurance claims, we've gone back and found out that you really weren't responsible for as much as you paid. And then if they can save their clients money, they get a percentage of what they save. That's how they make money. So if they identify and say, Aetna has a big insurer, overpaid by $100 million, then you get some percentage of that as a revenue. So their big problem was it takes 300 days for them to get data from the insurance company to the point where they can actually get paid on that. By the time they actually found the improper payments, and they don't get paid until they find value, right? So they can shorten that amount of time. That means a lot of money for this company. Again, the characteristics, they're collecting data again from third parties, from the insurance company they support. So data is not consistent. They need to clean and prep that data. Again, doing that really involves a subject matter expert. So it's not something they can automate. The existing process is in Excel, and you can access spreadsheets grabbing data. So again, very manual process. They do have data lake. They have in this case, with a 26-node Cloudera environment, where they're collecting data from third parties, but just getting value out of it took a long time. So anyway, the net results were able to really shrink that 300-day cycle down to 90 days by speeding up the data prep time. But for them, it's not just saving the time; it's a faster amount of time before they start getting paid. So going from 300 days before they start making money to 90 days with a huge improvement in value for their business. Okay, so I guess by way of summary, the world of data has changed. We've moved away from data warehouses to a much more layered and flexible data lake, but it's more raw than it's been before. And also the world of analytics has moved from again, highly curated and centrally controlled reports to more of a self-service model that's just widened the gap between data that's raw and people need to use it. So we need a new approach that fills that gap. And hopefully I've shown that to you today with Paxata. Thanks for your time.
All the data, and it involves participation.
It is, and that's one of the reasons we go back to flexible deployments. And that's one of the reasons we offer multiple deployment models. We found that we have a SaaS offering that we make available, but some customers prefer, for whatever reason, to keep the data on-prem. That's fine. We're software solutions. We use web software. Yes, sir.
So the question is sort of about curating the data. So how do you sort of detect legacy all sorts of data?
How you eliminate redundancy? Yeah, it's a. I think there's a broader challenge there. I think tools like Paxata can help. I don't know that we're sole solution to it. Part of being able to profile data is being able to understand what data is here. What are the you saw the filtergrams for what are the sets of values that are available in that data set that can help you understand what's in one data set for another, whether there's some overlap between those. I didn't really get to show you a full demo of some of their joined recognition capabilities, but that's a really good way to say, look at the similarity between these two data sets and how much similarity is there between the two. That's another way that you could identify some redundancy data sets. Again, I think it's probably a bigger problem than what Paxata is also. Yeah, I'll ask this question. Thank you all.